On October 5th, and then again on October 6th and 9th, all during 2023, a mysterious series of small magnitude tsunamis struck not only the Japanese mainland but also portions of the Izu and Bonin Islands. This thankfully did not cause any casualties, but the up to 70 centimeter or 27.6 inch high tsunamis were sufficient to capsize multiple boats on the islands of Kozushima and Hachichojima. While these tsunamis were almost immediately traced to a series of underwater earthquakes, it presented a major problem. The largest earthquakes in the identified sequence were approximately 22 times too small in terms of overall energy release to have generated a tsunami of that size, let alone one that affected coastlines up to 1,000 kilometers or 621 miles away. Thus, something else must have been to blame than just a typical normal, reverse, or strike-slip fault earthquake. While the topographic resolution of the seafloor is generally quite low because statistically very little of it has been explored, I previously identified the spot as a possible active submarine volcano or as part of the Sofugen volcano 19 kilometers to the east, mainly because it contained what looked to be volcanic cones and a caldera scarp. With evidence of an ancient caldera collapse, I suggested that these earthquakes were CLVD-type earthquakes, which can occur when magma intrudes underneath a volcanic caldera, causing it to be quickly lifted up on one side. This has occurred on land before at other world volcanoes and has been observed underwater beforehand, with these types of events being known to produce tsunamis that, while small, still far outsize what would be expected from an earthquake of that magnitude. Well, more than 2 years later, we finally have a somewhat concrete answer that, to be honest, makes the nature of the 149 magnitude 4 or larger earthquakes that struck in the earthquake swarm far more complex than previously expected. First, the October 5th and 6th 2023 tsunamis were not generated by ring faults or even CLVD earthquakes, but rather by highly vertical normal faults associated with a large and ongoing magmatic intrusion. But then, when we got to the October 9th tsunami, things get even weirder. It appears as though that last tsunami, which was the largest of the three, occurred while all of the following were occurring at the exact same time. 1. A lengthy 40-kilometer magma dike intrusion to the north-northwest of a previously unknown active submarine volcano called the Sofu Seamount. 2. An ongoing caldera collapse related to the withdrawal of magma into the aforementioned lengthy magma dike. 3. An actual volcanic eruption at the submarine summit of the Sofu Seamount. This formed multiple volcanic cones, which in one instance produced a lava flow so large that it led to the fourth item. 4. So much lava built on top of a 35-degree slope on the volcano's north that, when combined with the near-constant adjacent earthquake activity, it led to the generation of a landslide with a volume of more than 1/10 of a cubic kilometer. So, when combined, there was both a positive and negative volume change occurring at the same time, although I'd like to think that effusive caldera collapse was occurring too slowly to cause the largest of the observed October 2023 Sofu Seamount-related tsunamis. If we assume that the more than 1 square kilometer region that collapsed by more than 1,000 feet downwards on the seafloor directly translated 1-to-1 with the volume of magma in the aforementioned magma dike, then the magma dike may have contained around 450 million cubic meters of molten rock. Yet, if about a third of this erupted at nearby flank vents, then only 300 million cubic meters of magma remained below the seafloor, where it eventually solidified. As a result, I interpret that the submarine landslide was the source of the October 9th tsunami, which, despite occurring at a kilometer depth underwater, was still sufficiently large to generate surface ocean waves through displacement. Whether or not this volcano is a candidate for similar small magnitude tsunamis in the next century is uncertain, as at least one scientific paper argues that the first 2 tsunamis were actually caused by CLVD earthquakes. So, the debate is still ongoing. As a final note, I would like to give a special thanks to my new YouTube channel member AlexCo13368 for supporting my work.